say it's going from a high number to a low number. So how do we read this integral? This is how we read. This is the integral. This is the integral from of negative x minus 50 from x equals 3 to negative 4. Again, this is the integral of negative x minus 50 or minus x minus 50 from 3 to negative 4. So always say from this number, from the bottom number, 3 to negative 4. So we can actually go from a low number to a high number. Now look at this here. Delta x is our b minus a over n. So in our case, for part 1, what is our delta x? Delta x is actually 7 minus 3, and then over n. And by the way, n is a number which is a natural number. N is greater than 1. So this right here is 4 over n. So delta x is definitely positive. And then now, so that's delta x is positive. And then now, what is this f of x of k? Oh, that's this function right here. This is our function f of k. And now the integral is from 3 to 7. It's not hard to see in this case. In this case, what we have, that means if x is 3 to 7, then x squared must be what? So x, let me write this down. If x is from 3 to 7, so x is from 3 to 7, and many of you gave me an argument like this. If x equals between 3 and 7, then we know that the x squared is between 9 and 49. So this x squared is now 9 and 49. And so now what is the argument of the function? Yeah, this function right here. By the way, this function right here, f of x, this is the argument of definite integral, but we have a name for this. We call this the integrand. Again, f equals is called the integrand. The integrand is the function under the definite integral. Okay, so the function under the definite integral, that is inside the definite integral, that's called the integrand. That's the term, another term. Okay, that's the term. And then so in this case, x squared. So in our case, the integrand is x squared minus 9. So what is that? So from here, sorry, that's x squared minus 8. So what is x squared minus 8? X squared minus 8 is now going to be between 1 and 41. So it's not hard to see that this x squared minus 8 is actually between 1 and 41. And therefore, the conclusion is x squared minus 8, this is actually positive. Because they did between 1 and 41. So hence, this guy is actually positive here. So on number 1, this guy is actually greater than 0. Because every term of f of x of k times delta x is positive. So that will be 0. Okay? So now let's look up, how about this? How about example 2? We have sigma. So we have limit sigma. In this case, we have limit sigma. And then we have this right, limit sigma. And they have the function value times delta x. In this case, will the number 2 integral here, will this be positive or will that be negative? So let me put a boundary here. Will that be positive or negative? And that will be now from 1 to 2. Note that this is from 1 to 2. And note that the b is bigger than 1. So 1 to 2, it's from a low number to a high number. If the indefinite integral is from a low number to a high number, then that will be what? From a low to high, that will be plus. And then what is the function value? X squared minus 8. But x is between 1 and 2. So note that this guy is actually a negative value. So this whole thing will actually be less than 0. The number 2 integral will be a negative. So right now, I just want you to figure out whether this definite integral will be a negative number or a positive number. That's all. Okay? Now let's look at example 3. If you look at this guy here, what is this guy here? This guy will be limit sigma again. Will this be positive or negative? Limit sigma. And now the first thing is, how about this delta x? So we have the function value times delta x. So what is the sign of delta x? Now it is from, to figure out the sign of delta x, note that the delta x is b minus a over n, where the upper limit is b and the lower limit is a. But again, what did I say here? On definite intervals, the lower limit can be a higher can be higher than the upper limit. So the lower limit can be higher. So in this case, what is this? It is from minus 3 to 5. It is indeed from a low number to high number. So we can see that the delta x will be positive. And now, how about this x minus 100? So when x is between negative 3 and negative 5, plus 5, negative 3 and plus 5, will this integrand function, x squared minus 100, will that be positive or negative? Can you tell me? Is that positive or negative? Can you tell me whether this is positive or negative? Are you there?
I think it should be negative.
What? Negative right here. That's right. So this is x squared minus 100, and x is between what? Negative 3 and 5. So when x is between negative 3 and 5, what is the sign of this x squared minus 100? Oh, that will be a negative number, obviously. And so minus 100 plus. So that means the entire definite interval will actually be a negative value. Now, if you look at this guy here, what is that? Again, limit sigma. This is once again number 3 is limit sigma here, limit sigma, and then the function value. In this case, is always positive. X squared plus 2, that's a positive function no matter what the x is. And how about negative? How about the delta x? Delta x is going to be from negative 5 to 2, and that is actually positive. And therefore, this will be a positive number. Now, let's look at example number 6. Number 6 here, let's see what we have. So in this case, number 6 is the case where the lower limit is actually 3, and the upper limit is actually negative 5. Note that in example 6, now this is problem number 6, this is how the interval goes, from negative 5 to 3, but actually it's from negative 3 to 5. So this is our B, this is our A. A is our lower limit. That's our lower limit. That's our lower limit. And what is our x0? This A is our x0, and this is our x0. And this one, as you will see, is going to be weird. X0 right here. And this minus 5 is our B. And B is our upper limit. And this one is actually x of n. So in this case, what happens is this is x0, and the x1 is here. This is x0. And then this is x2. So we get this weird case where the x's are actually moving from right to left. And the last guy over here is actually x of n. Again, A is called the lower limit. Again, what is it called? A is called the lower limit in this case. A is called the lower limit. So let me write this down. So lower, and then limit. And B is the what? B is the upper limit. So once again, what is the upper limit of an interval? Upper limit of the interval is always what? Of the definite interval is always a number which shows on top. In this case, which is negative 5. Or this is our problem number 6. And then the lower limit is 3. So lower limit is not the lower number. Lower limit is the number you see on the bottom of the interval. That's the lower number. That's called the lower limit. It could be a variable too, like x or 2x. It could be x squared. It could be any function of x. So that's the lower. And then B is called the upper limit. Okay, so now in this case, what will be the sign of this number 6 definite interval? What will be the sign? The sign is going to be, in this case, it is going to be limit sigma. So we'll have some limit sigma here. Limit sigma. And then now the question is the function value and the delta x. Now, is the delta x positive or negative? Delta x by definition is always this. Delta x is equal to b minus a over n. Now, what is b? B is the upper limit, and a is the lower limit. And note that the lower limit can be higher than the upper limit. The upper limit can be lower than the higher limit, than the lower limit. So b minus a over n, in our case, is going to be what? In our case, it's going to be negative. Again, in this case, in example 6, what is the delta x? In our case, delta x will be, in this case, will be b minus a over n, which is equal to, minus 5, which is equal to minus 5, and then minus 3 is going to be b minus a, and then over n. And n, by the way, is always positive. You then represent a natural number. So we get minus a over n is always positive, so hence this actually becomes a negative number. So this guy is a minus. And now what happens to this guy right here? The integrand is x squared minus 100. When x is between negative 3 and 5, or 5, 3 and negative 5 and 3, or 3 and negative 5, doesn't even matter. Then what is x? Then how is x squared minus 100? And that one will be negative here as well. So in number 6, the integrand it will be negative, and the delta x will be negative. Hence, when we actually calculate this, we actually calculate and we will get 0 here. That will be 0. Sorry, that is not negative. I made a mistake there. That is a big mistake. It should be what? It should be positive. It will be positive. Any questions here? Just want to know the definition of definite integral. And the definition definition of definite integral, which you really have to know, is this one right here. The other one, the Riemann sum, and this one, you can look at it, but you'll have some difficulty because you may not know some of the notations here. But if we, in this class, if you just know this last definition right here, the last definition is the definition of definite integral with what? With the regular partition and using the right endpoint. So this is what's called the right sum. The right endpoint. If you use the right endpoint on each integral, what do we call this? We are going to call this the right sum. Right sum. And the right sum is as sum and then sub L. Sub R. That is. So we will call this guy sum, and then subscript R will be R, S sub R. That will be the right sum. If you now talk about the partial right sum, the partial right sum will write this as S sub R S. Okay? But here we're talking about the right sum, which is the limit of the right, which is the limit of the what? Of the n partial of the sum. N partial right sum. So we talk about this R sub S sub R, and then n. And this is what we call the what? It's called the n partial of the sum. N partial upper, and then sum. Okay, that's called the n partial upper sum. Okay? So n partial upper sum, that's how you write it. So in this class, we only talk about the n partial upper sum and the right sum, because this guy right here, the which I marked in the box right here, that guy right there is actually this guy right here. Is actually the n partial upper sum. And then once we attach the limit, and then we talk about this whole thing. This whole thing is now the right sum. Again, that's the in square bracket, the sigma f of x of k times delta x. That is the n partial sorry, made a mistake. It's not n partial upper sum. It's the n partial right sum. Made a mistake here. N partial right sum. Let me write this down. It is going to be n partial right sum. It's the n partial right sum, and then if you now pick the limit, that's called the right sum. Okay? Any questions here? So let's look at this. Now, which of these will be a negative here again? Yeah. You know what? Let me just do one here one more time. Now, let's look at these guys one more time here, and let's look at this example 1. How about if I look at this, let's say, number 3. Number 3. So number 3, what is this? You know what? Let me just move on to the next example, okay? Yeah, we already did this. I don't want to go over here. So let me just clear this. Then you get to the next example here, and now we have 1.2 examples here. Now, here, you've got example 2, 3, 4, 5, and then 6. All of these here, all of these, what are these? These are just practice. We have already done this before, okay? So, let's just quickly look at all of these here. So, how do you do this? So, let's say, for example, should we do 1? Should I do 1 here? How about, which one should I do?
You do number
Let's do,
5.
let's look at example 3. So let's do example 3 here. Example 3. Now this example 3, what is this? The integral from negative root 2 to 1 of x squared minus 4. Okay, so now let's evaluate this definite integral. So to evaluate this definite integral, what we need to do is this. So first of all, we have to figure out what the delta x is. In this case, what is the delta x? What is the delta x here? Can you tell me? What is the
Is
delta
it
x?
negative 2 minus 1 over n?
Yes, it is. It is negative 2. Oh, no, it's not negative 2. You have to take the upper limit.
Right.
The upper limit is 1. And then minus what? Minus negative 2. It is always b minus a, where b is the upper limit, and a is the lower limit. Now again, let me say this one more time. So on definite integral, this is the lower limit and the upper limit. However, it could be like this. As number 4, the lower limit is 3, and the upper limit is 1. So whatever number you see in the bottom is the lower limit, and whatever number you see, whatever expression number you see in the top right there, that's called the upper limit. But unlike the sigma notation, here is the definite, so the upper limit can be a lower number. Okay, is that clear? So in this case, what is the delta x? Delta x is equal to upper limit minus the lower limit, and then over n. And then it happens to be this, and this is equal to what? 3 over n. 3 over n. And then that will obviously be always positive. And then now, once we have that, then what is our delta? What is our x of k? X of k is now going to be this. Now in this case, we have this interval, and then from negative 2 to 1, this is our a, is our lower limit, and lower limit is always going to be x of 0. And then the upper limit in our case is 1, and this is our b, and the upper limit will always be x of n. So in this case, the delta x will actually be positive. Now what is x of k? X of k is a plus delta x. A plus k delta x. Again, if we call this x of k, if I call this x of I, then what is x of I? Then x of I is equal to a plus I delta x. By the way, when I was a student and learning calculus, I used in my the textbook I used as a student, we used the index variable I. By the way, this variable here is also called the index variable. In this case, I is the index variable, and so I'm very used to the index variable I. So we can use I or J or whatever letter. But our textbook is using K, so I'm using K now. But it could be I, or it could be J, it could be N, it could be any letter, right? Any letter not in use, cannot be X or Y, but we usually use X, K or I or J or M or N. These are the letters we use. So X of K is A plus K delta X. Once again, when you see the K here and K there, all we are saying is that this letter and this number right here, they match. That's all it means. That is all it means. There is no match to K. So don't just get used to K. Just know that this letter can be any letter. They just have to match. So in this case, delta x is this. So in our case, what is that going to be? Our a is going to be, our a is what? A is negative 2. That's the lower limit. The plus, k is the variable. And then what is our delta x? Delta x is going to be now 3 over n. So our delta, so therefore, this is our x of k. X of k therefore is equal to now what? X of k is equal to now negative 2 plus 3k over n. That will be our x of k. So for all of these problems here, the first thing is you have to figure out the delta x, and then you have delta x is this right here, and you have to figure out this right here, x of k. Okay? And this one you can always check. After you have found this x of k, always check. What is x of 0? X of 0, as you can see, indeed, it is negative 2. So now what is x of n? The last time. X of n should equal b. When you substitute k equals n here, what do you get? Yeah, we do get negative 2 plus 3, which is equal to 1. So that's it. Okay? So now what I'm going to do is now I'm going to save the screen here. Let me clear this. Yeah, I almost forgot. I do have another file here. Another file called the solution file, right? With solutions. Yes. I was trying to lately I've been, save up and trying to write all the solutions on my notes here to save time. So this is now section 4.A solution. Okay, so let's see what we have here. So what is it? Save, share. Okay, good. So this section 4.28 is exactly the same file, but this one now has answers. So yeah, I should have used this file. Then I didn't write copy all those things here on example one. Example one, I just wrote those. The question is whether the functional value is positive and the delta is positive, right? Yeah, we didn't know all that. So we can move on. Now let's move on to example two. Again, now we example two evaluate this. So how do we evaluate? We are asking example two. Which one were we doing here? Were we doing example three? Yeah, we are doing example three. Example three is this. Example three, the integral of x squared minus 4 from negative 2 to 1. So in this case, what is the delta x? Delta x is equal to 3. So delta x is 3, right here, then 3 over n. 3 over n, not 3. Delta 3. And then what is the x of k? X of k is a plus k delta x. And what is the a? A is always the lower limit. What is the lower limit? The lower limit is always the number which is found in the bottom of the integral. In our case, it's negative 2. Again, lower limit is not the low number. It's not the lower number of the cube. It is the number you find in the lower part, in the bottom of the integral part. That's called the lower limit. Again, lower limit can be higher than the upper limit. Okay, unlike the sigma. So we get this. And now we have this right here. That's an x of k. And always check x of 0 is negative 2. And x of n is 1. That's how you check whether you got the x of k correct or not. And then that is our kth interval. And then now we have Sn. All we are going to do is now what? We are actually in this case, did I say that we are using the upper sum? And is that correct? That is a mistake. I should not have written this x of eighth of k bar. That's actually upper. That is the upper triangle, the tall triangle. What I should have written is this one. I should have called it a sub r. That is the area of the rectangle created by the right angle. Yeah, mistake on my notation. But from this part right here, this is okay. So here, if you look at the interval from x to k minus 1, this is x to k minus 1 to x of k. This is our x of k. Again, this is our kth interval. So this is our kth interval, I to k. The question is, which point are we going to use to calculate the height? And if you use this point right here, x of k, that means we are using x of k right here, x of k. That tells us that we are using the right end point. Again, if you look at this guy right here, you see this x of k. That x of k tells us that we are using the right end point, and this is the right sum. This is not Sn. This is actually S. Actually, it is Sn, it's okay. But more specifically, this is the right sum Rn. So if you write Sn, it's not wrong for this problem. It is the nth partial sum. But this is the nth partial right sum. And so, the rest of it, again, is calculation. This is that right there. Plug into that. What is our f? F of x is, this guy is, what is our L? Yeah, here. Yeah, this guy, x squared minus 4, that is our f of x. And I'll plug that in there. Plug in this x of k, the function. So this is what you get. X squared minus 4. And then 2 of n is our delta x. And then I will simplify, and then use the sigma k squared formula here. And then you take the limit, and then at the end you get minus 9. Just want to let you know that the definite integral can be a negative number. Now, if you really look at the graph here, how does the graph look like? This graph y for the x squared minus 4 is going to look like this. So here, x, y here. How does this graph look like? This graph y is equal to x squared minus 4 looks like this. So we have an x is 2, and that minus 2 here. That's 2, and then this right here, and then now what? And then the graph, it goes all the way to negative 4 at 0, and then the graph goes like this. This is y is equal to x squared minus negative 4. So obviously this is a good graph. It's not an nice graph here, but anyway, this is the rough sketch of this graph. And now what? We're now taking the interval from negative 2, which is from here, negative 2 to 1. So this is 1 right here. And so we are doing this here. And so on each, so when you look at each term here, each term, the del x will chop with this. So we chop it up like this. If we chop it up, then we get this. And the del x right here will be positive. And then now when we multiply by the function value, the function value is actually negative. Note that function value is negative. Note that in this case, f at x of k